In this lecture we will see theta notation. Previous lecture we understand about big O and omega notation. Theta notation, symbol is theta, and if there are two non-negative function, that is f of, first is f of n and another is g of n, we can write f of n equal to theta of g of n if first condition f of n is lesser than equal to c1 dot g of n, and another condition is f of n should be greater than or equal to c2 dot g of n. As we discussed in previous lecture, this is nothing but omega and this is big O and this is omega. So theta is nothing but any two given non-negative function, if it is hold good for omega as well as for theta, for omega and for big O, then that function will be theta. Okay. Now we will see one or two example to understand this. Let's take first example. If f of n equal to n and g of n equal to n plus 5. Okay. Now is it f of n, we can write it omega of g of n? Yes, we can write. Take any, we will take one c value. Just take for if we want to prove that for omega, we need to prove that left hand side is greater than right hand side somehow by taking any constant c. Okay. Now take n, it is left hand side, n is greater than equal to 1 by 2 n plus 5. Okay. And we need to find n naught for all n, and n is greater than equal to n naught. Now we need to find n naught. For that from n naught towards all the value which is greater than n naught will hold good for this condition. Okay. Now take example from 1 to, no, take example n equal to 1. For n equal to 1, n plus 5 plus 1 6, 6 by 3, 6 by 2 equal to 3. Left hand side is lesser than right hand side, so 1 is not possible. Take some 2 value, 5 plus 2, 7, 3 point here 3.5 5 and here 2, that is not greater than or equal to 2. Take another value, that is 3. 3 plus, not possible, because here 3 plus 5 8, 8 by 2 4. Now take 4. 4 plus 5 4.4, not hold good, because here 4.5. Now take 5. 5 and here 5 plus 5 10. Yes, this is equal to, okay, from 5, if we take n naught as 5 for omega, then greater than all the value greater than 5 will hold goods for this condition. Take 6, here 6, 11, 11.5.5. okay. Now for omega, that is C1 equal to 5, C1 equal to 1 by 2, and n naught for omega equal to 5. okay, all the value greater than 5 will hold goods for this condition, that is f of n is f of n is omega of g of n. Now we need to prove that right hand side is greater than left hand side somehow by taking any constant value c, and for c value we will also need to find n naught for omega, also for big O also. Now try to prove for omega. F of n is n C2 dot n plus 5. Now if we take C2 as 1, and then if we take n value n not equal to 1, then 1 lesser than equal to 6. So by taking n not equal to 1 and C2 equal to 1, we are able to make proof that f of n is big O of g of n. okay. Now we need to find there is 2 n naught value, and we need to take one value, that is upper limit, tightest upper limit from big O and from omega. okay. Now if we want to write, now this is for omega, and for this is for omega, and this is for big O. Big O C1 equal to 1 and n naught equal to 1. Now if we want to write that f of n equal to theta of g of n, then we need to find n naught. okay. Then f of n, we can write f of n equal to theta of g of n for all n is greater than equal to n naught, where C1 equal to 1 by 2 and C2 equal to 1. Now n naught equal to 5, which is the greatest value. We will take that value for theta. okay. Now take this example. We prove same type of example for omega and also for big O. Now we will prove this example for theta. If we want to write f of n equal to theta of g of n for this equation, for this given f of n and g of n, we need to find c1 and c2 and also n naught. Okay, now first try to find c1, and for omega we solve this for big O. Okay, now prove f of n equal to big O of g of n. Now first we will prove this, and if we want to prove f of n equal to big O of g of n, then somehow by using any constant value we need to prove this, that right hand side is greater than left hand side. Okay, now prove. This is right, left hand side n squared plus n plus 10 equal 10, and here n square. Okay, now we will take c1, some value c1, and if we take c1 as 2, and we also need to find n naught, that from that value, if we go or increase value of greater than value of n naught, this condition will hold true. Okay, then fine. Now n naught will be, now put from 1, 2, 3, 4 and 5. I am directly putting that 4 for, and if we take 4 and not, then from greater than 4 all the value will hold true, from 4 to all the value greater than 4, this condition will hold true. Put 4, 16 plus 4 plus 10, here 16 into 2 equal to 32, and this will 16 plus 4 20, that is 30. Or okay, now we have find our c1 value equal to, for omega c1 value will be 2 and not equal to 4. Okay, now we need to find some for omega. Now take f of n. So if we want to prove that f of n is omega of g of n, then somehow by using any constant value c, we need to prove that left hand side is greater than right hand side. Okay, for that f of n value is n squared plus n plus 10. It should be greater than equal to n square, that is g of n. Now if we take c value as 1 by 2 and not equal to 1, put 1 plus 10, here 1 by 2 into 1. So from, if we take n not equal to 1 and c2 equal to 2, then this condition is hold true for the given example. So in omega c2 equal to 1 by 2 and n not equal to 1. Now we need to write it in theta, and also we need to find n naught. N naught will nothing but whatever the greatest, you can take that value, that is 4. From 4 onward both condition will hold true. Now write in the term of theta. F of n equal to theta of g of n for all n if C1 equal to 2 and C2 equal to 1 by 2 and n naught n is greater than equal to n naught and n naught equal to 4. Okay, if you have any confusion you can write on comment box. Thank you.